Hello and welcome to Chemistry Talk with Hunter. I'm Hunter and today we'll be discussing oxidation numbers, how to assign them, and the basic rules. So these are the most of the rules for oxidation numbers. Elements in their pure element form have no charge. The group 1 metals are always +1 unless by themselves. Group 2 metals are always +2 unless by themselves. Hydrogen's always +1 with a nonmetal but -1 with the metal. And oxygen is -1 only in peroxide, always -2 otherwise. Okay, and one more important rule is that the oxidation number of a diatomic element is also 0, but that wasn't in there. Okay, so let's begin here. So we have potassium permanganate, and if you don't see a charge indicated, that means the net charge is 0. So all the charges of each element in here individually have to add up to 0. So what do we know? We just read a rule that says that oxygen is always -2 unless in a peroxide. So here oxygen's total charge is -8. We also read about group 1 metals. They are always +1 unless in their elemental form. So now we have a charge of -7. And we need to get the total charge to equal 0. So we're hoping that manganese, well, it will, somehow balance this out. So there's a couple ways to think about it. You can write an equation where x minus 7 equals 0. You're looking for x here, and if you solve for x, you get 7 plus +7. And that would be the charge of the manganese. 7 plus -7 gives you 0. So that means the charge of Mn, or the oxidation number, is +7. You could have also seen that if you have a -7 and you want 0, a +7 would balance that out. That's another way to look at it. Okay, moving along here. Okay. What is the oxidation number of iron in iron chlorate? That should say iron. Okay. So, we're given iron chlorate, but I don't know which form of iron it is. It's ambiguous. It doesn't tell us. So that's what we need to find out here. As iron is a transition metal, its charge should always be indicated. So let's see what we have going on. We have a chlorate. We have 3 chlorate ions, and each chlorate has a -1 charge, which means that the total charge on 3 chlorates is -3. So that would tell us that this means that iron's charge, or oxidation number, is +3, which means that this compound is actually iron 3 chlorate. So that wasn't too bad. That's how you would do that type of problem with any transition metal. It's the same thing. Okay, now we're given carbon monoxide, and we want the oxidation number of carbon. This one's pretty simple. You know oxygen's always -2 unless in a peroxide, which means that carbon would just have to be +2 to make that 0. So the oxidation number of carbon and carbon monoxide is +2. Okay. Here we're given iodine, and we are asked for the oxidation number. Well, a couple things to note here. Iodine's a diatomic element, so that's why it's 2 there. But I also mentioned a rule in the beginning that the oxidation number, of diatomics is 0. So in this case, the oxidation number of iodine is 0. That's just another rule. Okay. Now we're given strontium in its elemental form. That's also another rule. It said that group 1 and 2 metals, when in their elemental form, have an oxidation number of 0. So don't be tricked and say, well, strontium's a group 2 metal and has a +2 charge. That's right, but its oxidation number is 0 because oxidation number rules say that elements in their elemental form, group 1 and group 2, are 0. Okay. All right, so this is a different type of problem here. We're given sulfite and we're asked for the oxidation number of sulfur. But the sulfite ion has a charge of -2. So what do we do here? All right, let's take a closer look. So we're given sulfite. Well, let me change colors here. We're given the sulfite polyatomic ion, and it has a fixed charge of -2. Sulfite. Not sulfate, don't get confused. Sulfite has a 3, not a 4. And we're asked for the oxidation number of sulfur. Okay, here's how we'll do it. Actually not too bad. So we were told by the rules that oxygen always has a -2 charge unless with a peroxide. So that means that oxygen has a -2 charge, which means it has a total charge of -6. And we know that the whole thing, it has to equal -2. So we set up our little equation there, if you can't just see it without a visual. So -2 plus 6, so we get +4, which means that the charge of the sulfur, or the oxidation number of sulfur in sulfite, is +4. Why? Because oxygen has a fixed charge of -2 in this case. There's 3 of them. -6. And we need the total charge to be -2. So 4 minus 6 equals -2. So that's how we got the oxidation number of +4 here. Okay, last one. Whoops, okay. So here we are given chromate, another polyatomic ion. And we're told once again it has a -2 charge. So we're going to do a similar thing here. We know that oxygen has a fixed charge of -2. There's 8 of them here. So x minus 8 equals -2. X equals +8 here, +8 here, which means that the charge on the chromate is +6. So the oxidation number of chromate is +6. You can double check that by saying 6 minus 8 equals -2. Sorry, 6 plus -8 equals -2. Because you add the charges and you get the net charge of -2. And in this case, it would also be plus a negative. So 4 plus -6. So I hope this helped you to understand how to assign oxidation numbers. Once you get good at it, you don't need to necessarily write the equation. You can kind of see it in your head, but there's no harm in writing the equation. So we'll definitely do more videos on harder compounds with oxidation numbers, but I hope this helped. Ask any questions in the comments or request any videos.